Okay, it's time to talk logarithms. And to start off with this topic, I want to talk to you first about logging in and logging out. So, right, let's kick off with the statement 2 to the power of 3 equals 8. It's a good place to start, isn't it? Okay, now that is exponent form. I can rewrite this as the log of base 2, log of 8 to base 2 equals 3. So open up my notes there, equals 3. So these two statements are exactly the same. They're the same equation. This is logging in. So when we talk about logging in, we're inserting a log into the statement. This way here is logging out. Going this way is removing the log, but they both say the same thing. So I want you to see this. I want you to see this first and foremost. The most important thing to understand is how to read a logarithm. Okay, and this is how it goes. 2, the base 2, we call that a base as well. This is base, this is exponent. So the base holds, and it's probably the easiest thing to transfer into a log statement. So the base 2 there, this is a base. So this is the base of the logarithm. This says the logarithm of 8 to base 2. The logarithm or the log of 8 to base 2. And what it says is, what do you need to raise 8 to? Sorry, what do you need to raise 2 to get 8? To evaluate a logarithm, that's what it's saying. What do you have to raise 2 to get 8? And the answer is 3. I have to raise 2 to the power of 3 to get 8. And so these two statements are equivalent statements, logging in, logging out. So the way to read a log is this value here, this base, to this power equals this. Okay, so if we can look at that another way, let's evaluate the logarithm of 49 to base 7. So what that's saying, so this has a value, the log of 49 to base 7. What it's saying is, what do I need to raise 7 to get 49? I've got to raise 7 to 2 to get 49, don't I? So that'll work for that. What's the logarithm of 27 to base 3? 3 to the power of 3 equals 27. Okay, let's keep going. Log of, let's do something like, hang on. Let's do something like base 5, 1/5. So 5 to the power of what gives us 1/5? Or 5 to the minus 1 gives us 1/5. So you can see that indices and logarithms are very closely related. That we need to have a good understanding of indices to understand logarithms. Let's go over here and do some more examples. I might say to you, what's log base 4? What do we raise 4 to get 2? And you think, oh, what's that? Well, the square root of 4 is 2. Oh, so that's a half, isn't it? 4 to the power of a half equals 2. So I can say underneath that, because 4 to the power of a half equals 2. And that 4 to the power of a half is the square root of 4. This is because 5 to the minus 1 is equal to 1 over 5. This is true because 3 to the power of 3 equals 27. See, logging in, logging out. Logging out here, this is true because 7 squared equals 49. You see how these numbers connect? This to this equals this. This 3 to the power of 3 equals 27. This is how they connect. 5 to the minus 1 equals a fifth. So that's how to interpret, that's how to understand a logarithm and to work with it. Okay, so we're going to have a look at some log laws now. Some laws of logarithms. Well, sounds very serious. Laws of logarithms, and as we're doing these, we'll go through some examples as to how they work. There are 3 of them, so it's not going to be too onerous a task to get through these, but it is a little bit, right, let's just get on with it. So laws of logarithms, the first one is taking base A here, is a product rule of logarithms, right? So we're just going to go through the laws of logarithms. 1. So the product rule here, log of a product will be equal to the sums of the individual. Okay, and again, look, this is what I want to emphasize here, is that product and sum are related when it comes to indices, because when we've got the same base, we add the powers. And with division, we subtract the powers, don't we? So you'd expect here that when we do a division of a log, that we might want to subtract the powers, like so. So an example here, let's do a little example. Log 200 plus log base 10 5. Right, now this is equal to, we're working backwards here, aren't we, with this? So we can see we've got the same base and we're adding, so that must be 200 times 5, or 1,000. So the log of, no, this is saying 10 to the power of what gives me 1,000. So the result is 3. I'll do an example here of the division. We might say log 32 to base 2 minus log of 8 to base 2. This is saying 2 to the power of what gives 32, so that's actually equal to 5, isn't it? And this is saying 2 to the what equals 8, so this value here is 3. 5 minus 3 is 2, we'd expect. Let's use the division law. 32 minus 8, my m is 32, my n is 8. So this should be equal to the log of 32, so that's not an a, that's a 2 there. Log of 32 over 8, which is log of 4 to base 2, which is 2, which is what we expected it to be. And the third law of logarithms that we're going to use is what I like to call the plog law. It's when we've got a power, log a of m to the power of p. Okay, so it's m to the power of p that's been taking the logarithm to base a. We can bring that p down so it spells plog. So when we talk about the plog law, that's in there. It's bringing the p down the front. So a little example for that one. This is a really useful one, and you'll find that when we're solving some equations, we're going to use this. Let's look at 3 log, let's unplog it, base 3 to the power of 4. This is going to be, if we unplog it, so that p comes back out. So this is in that form. We're going back this way. The p is going to go up here. So look at this. The 3 comes back up into the cube there. So that's equal to the log base 3, 4 cubed is 64. So 3 to the power of what gives us 64. So that's just, actually, we can't simplify that. There's no whole number answer for that. So that unplogs. I'll do another example with this one. It's maybe solving an equation that we did in class, where we might want to solve 2 to the power of x is equal to 5. This came up where we thought, oh, it's more than 2, it's less than 3. So if we take the log of both sides, I'll show you how logs can be useful. We'll take the log of both sides. It's a perfectly legitimate thing to do. Take the log of both sides. Now this, when there's no number written here, it's assumed log base 10. That's the default value for log. So log base 10, that's what we take. Then what we can use is the plog law here to bring this x down. So we get x log 2 is equal to log 5. So we've used the plog law there using plog. And then we go, therefore, x is equal to log 5 over log 2. We can get our calculators out and go, alright, let's get back into calculator mode here and go for control log, actually it's going to have to put the base in there, log 5 arrow across divided by log, that hasn't worked, we're going in there with a log 10, that's completely stuffed. Okay, so you can see there I've just done the calculation. Log 5 divided by log 2 is 2.32, so I can go back in and write 2.32. We knew it was between 2 and 3, but that gives our answer to 2 decimal places using the PLOG law there. We might want to just do another couple of examples here. We're on 10 minutes. Just do a couple more examples. Let's have a look. What would be useful? So let's have a look at solve log base 5 of x is equal to 3. So unlogging, this says 5 to the power of 3 is equal to x. 5 to the power of 3 is equal to x. So therefore x is equal to 125. So that all we need to do there was just unlog it, just log out. Do another example of a similar type. Log base 5, 2x plus 1 is equal to 2. 5 squared is equal to 2x plus 1. So therefore 2x plus 1 equals 25. And we can go and get 2x is equal to 24 and x is equal to 12. Get it that way. Let's look at, let's say, log base 2, 2x plus 1 minus log base 2, x minus 1 equals 4. So we're going to use log law 2 here. Log m minus log n is equal to log 2x plus 1 over x minus 1 equals 4. And then we can unlog it by taking the 2 out and bringing it to the 4. So 2 to the power of 4 is equal to 2x plus 1 over x minus 1. Multiply, this is 16. So I'm just rewriting this. And I'll put the 16 on the right hand side now. 2x plus 1 is equal to 16x minus 16. And therefore 14x is equal to, is that 17? So x is equal to 17 over 14. Okay, that'll do us for examples. I'm sure there'll be lots more questions as we get into it, but we can now go in and have a look at exercise 15E starting page 426. I'll see you next lesson.